Maybe you've been out on the water on a Saturday and seen a line of power cruisers tailing each other around the buoys. What you may have just seen is the San Diego Cruiser Association out on a predicted log competition. Here's how it works. The association sends out a finishing time and a course that may have 6 to 10 required points on it. These can be buoys or other physical objects on the water, or they can be simply a latitude and a longitude of a point on the water where no physical object exists. The navigator plots this course on his chart. Since he's been given a finishing time, he must work through the course backward to determine what time he must start the race. He takes into consideration tidal influence and perhaps how much the wind will affect his vessel as he runs the course. He then turns this predicted log into the association before the competition. On the day of the competition, each boat has an observer aboard to ensure that only a compass and the RPM of the engines are used. No clocks can be used at all, with the exception, however, of a stopwatch that can be used on the legs where the point is simply a latitude and a longitude. At each of the required points, the competitor calls out, "Mark," as he draws a beam of the point. The observer notes the time on the log. At the end of the course, each of the points have been logged by the observer. This log is compared to the predicted log, and the vessel that has come the closest to the prediction wins. Well, let's take a ride with Captain Bob Ellers as he runs his predicted log. We'll also be given some pointers on navigation by Captain Gary Adalian.
Ready on the start? Ready?
Ready.
Bring him up, bring him up, bring him up.
30 seconds.
Ready on 16A, a beam for the start. Ready?
Ready.
Mark.
I'm Gary Adalian, and I'm a member of the San Diego Cruiser Association. Predicted navigation, we do that once a month on our Saturdays. I do it the old-fashioned way. I do it with the old dividers and measuring. Now a lot of people are using computers, of course. And
we have digital tachometers here, so we can kind of nail them down if the engines will cooperate. 100 RPM difference makes a quarter of a knot of speed for us, so we've got to be pretty close.
We're given a copy of the race instructions for each race. Each race is different. This particular race starts at CB19, which is a buoy right off of Shelter Island, and it starts there and continues on down San Diego Bay. So what I attempt to do is that I have to plot the course and then measure the course and the headings and go through in each step at a time, each leg at a time, add the currents, predicted currents for that time based upon my finish time. We're all given individual finish times. We finish at about 3-minute sequence apart, and we have to base it upon that and figure out the start time, working the whole race backwards.
20, we have to leave it on the right-hand side. It's Mark 1. This is the first timed leg of the course right here. It's between 16A and 20. And this is our calculations. We have to end up at CB20 from 16.
Okay.
One way or another we have to get there, and the way to stay in the middle of the harbor and go with known currents is to go out where a buoy is that we have data on. So we're going between 16A and 18. We have to go to 20. That's part of the specified race. So we're going to round 18 here and go straight over there, and when we pass that, it's going to be on our right side. And then we're going to head toward an unknown place, which I'm going to time, and it's somewhere off of the cruise ship here. And that's going to be not a known location, but a location where we go for a certain heading for a certain time. It's kind of a timed run or a blind run. You just point your boat in that direction and start the watch. When you get there, you stop the watch and you have to turn at that time. Once again, you don't really know where you are.
Is a latitude longitude, so I have to plot that, and that's 3243 16 north, and the 16 north .43 16 north is there, is 1217 117 1202, which is there. That course will be 54 degrees magnetic, and the distance, I prefer a method. I use millimeters and convert it to nautical miles, or percentage of nautical miles. This particular case, it's 151 millimeters, 154.5 millimeters per nautical mile on this particular chart. 0.977 of a nautical mile.
See, if we end up in the wrong place here, then it's going to make our run shorter or longer down to there, and there's the run for the money. This is the next set of marks. So we really have to be in that X in the water there to get over there at the right time. If we end up north or south of where we're supposed to be, we're either going to be fast and slow for the whole leg. 50 seconds. Keep on heading south. 3, 2, 1, turn.
And when this gets completed all the way to the very end of the race, then I can take my tide sheets and my current graph that I have here, and I can start working the race from my finish time, my given finish time, and work the race backwards all the way back up to the start. Figure my speeds based upon the current and work that leg, and then get a time for the previous leg, and then work it all backwards that way until you get to the very end. This particular spreadsheet will take about 2 to 3 hours.
22A, a mark of the course to starboard. Ready on 22.
Ready.
Mark. The center channel is those two right there between 20 and 19 and 19 and 18. That's a navigable channel that the ships go in and out of. Mark.
Okay, I'm Catherine Isaacson. I'm the official scorer for the San Diego Observers Association. And at the end of the race, the cruisers turn in their green sheets that the observers have filled out, and I enter it into the computer and get the official scores.